Hi, this is Ryan Gates with my final weather project, the Understanding by Design activity. For the learning goals for the activity was that the students will use models and online activities and explore the relationship between ideal gas laws and relative humidity. The student will also recognize this relationship in their daily lives. The state standard that I used was H2, and its interaction and change. That means the components in a system can interact in a dynamic way that may result in change. And system changes occur with a flow of energy and/or transfer of matter. And then the next generation science standard that I chose to use was change and rates of change can be quantified and modeled over very short or very long periods of time. And some systems change are irreversible. The evidence of learning are based on the two activities that I have, plus discussion questions. The answers to the lab activity questions are one way of evidence of learning. Answers to the final humidity exercise is also another way of learning, of evidence of learning. And the last evidence is that doesn't relate specifically to answering questions, is that the discussion questions and their interactions with other students based on the concepts of that they learn are the evidences of learning. So I have the discussion questions, and the discussion questions are the last thing I'm going to look at. I put these out of order, but the learning activity is a FET learning activity, which is a online activity. This is the FET interactive simulation that I was going to use. It's called Gas Properties, and it runs through a JavaScript, and the students can play around with a variation of not topics of varying variables in to find the relationship between temperature and pressure. This is the activity that we'll be following. It's as you can see, it says the relationship between volume and temperature. Excuse me. And it goes through and it talks about it runs them through. It tells them to try and get through it. And then what I like about this one is that it has them build a model of graph and graph the results based on the results of what they did in terms of volume and volume on the horizontal and temperature on the vertical axis. And then ask them questions based on those things. And then again, this one is the relationship between pressure and volume. And then they do it again, and then it goes through, and then they can say combined gas losses. So how does it work together? Volume and pressure, and volume and temperature. So relationship of temperature and pressure, and you can see that initial values for everything, and then time permitting what they go through, and then it has them answer some questions based on the combined gas law. Now, based on that, they will then in turn and excuse me, sorry. They will use the discussion questions. And the discussion questions at the very end. The relative humidity questions is what they'll go to next. And the relative humidity question is going to be based on this calculation of relative humidity, and it explains what relative humidity is. It's the ratio of amount of moisture actually in the air to the maximum amount of moisture that the air can hold at a given time. So it comes down and it shows them, okay, so if the absolute humidity is 15 grams at 25 degrees, which is what it says, so at 25 degrees or 77 degrees Celsius, then it's 15 grams. The saturation is 23 grams, so that's the total amount. And currently it's right now 15, so 15 divided by 23 grams, and it gives you 65% relative humidity. So based on those, I have them calculating different times of relative humidity, but basically focusing on them inside their house. And that forces them to think about the relationship of relative humidity in terms of air conditioning and in their daily life and how they experience it and how it's different from the outside versus the inside. And those then leads to the discussion questions, and the discussion questions are questions that focus on how it interacts in their daily life. And so what I did, I didn't do it with my students because towards the end of the year they were already past combined gas laws um, for chemistry, and so I used my teachers, my fellow teachers, and I used through Google Docs. So they obtained the Fed activity through Google Docs. They then completed the activity. They then used the same Google Doc to obtain the humidity activity. And after the completion, I just had them answer one discussion question, but they did not um, interact with amongst themselves. So as I was going through this, I thought it was a little too difficult for the teachers who didn't understand science, which is understandable because it is a chemistry problem. And ideally that it's a chemistry topic that comes in the second half of the year. Um, I also was, as I was they were going through it, and as I tried to do it myself, um, I was questioning if there was enough connection between the humidity exercise and the gas property exercise, or was I just making a giant leap because I understand it and not having any bridging activity in between. Um, Now, I like that it was the teachers that were testing this because they can be more honest with me and tell me, how it worked and it didn't work, and if it was a good experience for them. Because this is something I might, be looking to try and integrate into my curriculum in the fall is things like this. I don't think it was a good experience because there was not enough, like I said, a connection between the two activities, and the two activities was a disconnect. And the discussion is always a great thing to have, and I think that I can always find a way to have a discussion. But the two activities were just not enough. Like I said, when evaluating the experience, um, sorry, when I was talking about the analysis, there was a disconnect in the terms of the teaching situation. I presented one activity, which talked about the gas laws, and then I presented a second activity with the humidity exercise, but there is nothing that says, oh, and relative humidity relates to the gas laws this way, um, with and that disconnect then led to confusion with those students or learners that I was presenting it to, and the missing component that will help all that tie that in together is supposed to be in the discussions, but it doesn't end up in the discussions because there's still a disconnect between the two activities, and so there's got to be something more to this unit. So my conclusion would be that I do need that bridging activity between the Fed exercises and the humidity exercise, and the bridging activity has to be more than likely a video lecture, where it helps them think about all that they have done in the Fed activity and then ties it into humidity and climate and those types of things, because there's a lot more to humidity than just calculate that calculation, because I'm just having them do, hey, this is relative humidity, but really, how does that work? How does humidity work with the combined gas laws? I thought, I could make that jump, but I not even the science teachers can make the connection between how vapor, the amount of vapor and temperature, and how it changes based on the temperature change. So the other thing I was thinking about, for time wise, I think that I need to spend more time on the transition between the two activities, because I spent all of my time on each individual activity. So I spent working on the Fed exercise, or working on modifying a previous exercise from somebody else and then modifying that to fit my needs. And then I worked on the humidity exercise on its own and modified it and did all those types of things that I needed for that one, and then I worked on the discussions. So I didn't think about the transition between each of them. So more time needed to be spent on how do I connect the Fed activity to the uh, other activities, and then that time spent there will be more effective than just the activity that I just had. And that is my project. I know I got a lot out of this, despite not being able to present it to true learners. It really helped a lot in terms of using understanding by design and going farther on those. It also helped me put together my thoughts on humidity, and when I teach it, I learn it better. And overall, I thought this was a great activity.